this question is simply crying out for recursion. We're given a recursive formula for the Stirling numbers, which is s of nk equals k times s of n minus 1k plus s of n minus 1 k minus 1. What we need to think about though is the base case, which isn't given. So when do we stop? Well, if we have some objects and we want to split them up, if we have more piles that we're going to split them in, some pile will be empty, and that's not allowed. So that means that if we have more piles, now piles is the k and object is the n, if we have more piles than objects, we want to return 0. We can't do it. So that's one case. If we look at our formula, we need to stop in other cases as well. We can't just return 0 all the time because then our sum will be to 0. So what happens when these two values are the same? Well, if the two values are the same, if n equals k, then how many ways are there of splitting up the objects into the same number of piles as there are objects? Well, there's just one way. The other case we need to consider, or we can consider, is if k is 1. What if we want to split the objects up into one pile? Well, there's only one way to do that, so we can return 1 there as well. So now to look at the code, and I'm just going to code those two conditions. If we have fewer objects than piles, then there are no ways to arrange the objects. If we have the same number of objects as piles, or if we have just one pile, then there's one way to do that. And if we're in neither of those cases, then we're going to return the formula that we were given, the recursive formula. And that completes the Stirling number part of the question. For the Bell numbers, we just need to sum the Stirling numbers for k equals 1 up to n, as stated. So we need a variable to keep track of the total that we're going to return, and then we need to step through the values of k from 1 up to n. So for k in the range 1 up to n plus 1, don't forget the plus 1 on the end because range stops 1 before the second input number. And then we just need to add the Stirling number nk. And finally we need to return the total.